everyone. So let's go back to solving problems from the book. So let's go start with problem 6. So problem 6 says if A is congruent to B mod n and K divides n, is it true that A is congruent to B mod K? Question mark. Yes, it is true. Yes, because if A is congruent to B mod n, then you have n divides A minus B, but you also have that K divides n, which in turns divide A minus B. So that means that K divides A minus B. And we're done. So there is a little bit to be said here, is that sometimes like transfer of structure is very, or actually in this case transfer of information allows, because structure is more general than information. Transfer of information allows us to deduce things about algebraic datum that we wouldn't really deduce otherwise. It's very interesting to think about things in that way. So let's move on to the next question. If A belongs to Z, prove that A squared is not congruent to 2 modulo 4 or to 3 modulo 4. So what we can do is that we can apply the division algorithm. So by applying the division algorithm, what we have is the following. We have that A is equal to 4 times K plus R, where let's make it let's make it 4, whatever, where R is between 0 and 4. So A squared is equal to 4 times 4 times K squared plus 4 times 2 times K times R plus R squared. So then what you get is 4 times Q plus R squared. So then if you get if you get 3, first of all we cannot if we get 3, so let's try 0. You don't get anything about what you want to achieve. Let's try 1. If we get 1, then oh man, sorry about that. My cat jumped on the cables. So if we get 1, we also then don't get anything that we want to achieve. If we get 2, then we will have 4. So that's congruent to 0, 0 mod 4. And if we get 3, you get 9, which is congruent to 1 mod 4. And so by all the choices, by selecting all the choices, we don't get 3 modulo 4 or 2 modulo 4. So by selecting all the choices, we don't get 2 modulo 4 or 3 modulo 4. And we're done. So yeah, let's move on to the next couple of questions and move on from there. I'll see you guys in the next video. Bye now.